Have you ever wondered why weather forecasts are so notoriously tricky beyond a few days? Why a prediction for sunshine can suddenly turn into a torrential downpour, seemingly out of nowhere? It feels like the universe is playing tricks on us, but what if the explanation lies in something far more profound? Something as tiny and delicate as the flap of a butterfly's wing? Today, we're diving into one of the most captivating ideas in all of science: the butterfly effect, and the mind-bending principles of chaos theory that underpin it. Get ready to have your understanding of cause and effect profoundly shaken, because we're about to unveil the hidden unpredictability lurking within our seemingly predictable world. Our story begins not with butterflies, but with a meteorologist named Edward Lorenz in the 1960s. Lorenz was using one of the earliest computers to simulate weather patterns. One day, he wanted to rerun a simulation but save time, so instead of starting from scratch, he entered numbers from a printout in the middle of a previous run. The original simulation used numbers like 0.506127. To save space on the printout, he rounded it to 0.506. A tiny, almost imperceptible difference. But when he came back later, the new simulation hadn't just diverged slightly, it had veered wildly, creating a completely different weather pattern. This was the aha moment. Lorenz realized that even the smallest, most insignificant changes in initial conditions could lead to drastically different outcomes in complex systems. He famously coined the term, "A butterfly flapping its wings in Brazil might set off a tornado in Texas." This wasn't just about weather, it was about a fundamental property of certain systems. So, what exactly is the butterfly effect, beyond a poetic metaphor? It's a vivid illustration of sensitive dependence on initial conditions, a cornerstone of chaos theory. Imagine a single snowball at the very top of a vast, complex mountain range. If you nudge it a millimeter to the left, it might roll down one valley. Nudge it a millimeter to the right, and it could end up in an entirely different valley, miles away, taking a completely different path and picking up different amounts of snow along the way. The initial tiny difference in direction gets amplified by the terrain, the wind, the slope, leading to a massive divergence in its final destination. Chaotic systems are like that mountain range, highly interconnected, nonlinear, and full of feedback loops where small inputs can rapidly become huge outputs. It's not about magic, it's about the intricate, compounding nature of certain interactions. Now, this is crucial. Chaos theory isn't about randomness. That's a common misconception. When we talk about randomness, we often mean something completely unpredictable, like rolling a die or flipping a coin. The outcome is genuinely uncertain. Chaotic systems, however, are entirely deterministic. If you knew every single variable, every force, every tiny interaction with infinite precision, you could theoretically predict their future perfectly. But here's the catch: infinite precision is impossible in our universe. We can never know the exact initial conditions of any real-world system with absolute certainty. Even the tiniest rounding error, like Lorenz's 0.000127, is enough to send our predictions wildly off course. So, while chaotic systems follow strict rules, their extreme sensitivity to initial conditions makes them practically unpredictable over the long term. They are predictable in principle, but unpredictable in practice. Once you understand the butterfly effect, you start seeing chaos everywhere. Of course, weather and climate are prime examples. The Earth's atmosphere is a colossal, chaotic system. A slight change in ocean temperature or a gust of wind in one part of the world could ripple through the entire system, leading to unexpected weather events weeks or months later. But it doesn't stop there. Ecosystems, with their intricate food webs and complex species interactions, exhibit chaotic behavior. Stock markets, with their countless human decisions and interconnected algorithms, are famously chaotic. Even the human heart, under certain conditions, can show chaotic rhythms, which, surprisingly, can sometimes be a sign of health and adaptability, not just disorder. From the dripping of a leaky faucet to the flow of traffic, the principles of chaos theory reveal a profound interconnectedness and sensitivity in the natural world. So, what does this mean for us? Does it mean prediction is futile? Not entirely. We can still predict chaotic systems over short timescales, like a 3-day weather forecast. But it teaches us the inherent limits of long-term prediction and control. It pushes us to think about systems differently. Instead of trying to pinpoint exact outcomes, we focus on understanding patterns, probabilities, and the asterisk range of possible behaviors. It encourages us to appreciate the delicate balance of complex systems and the potential for small interventions to have enormous, unintended consequences, both good and bad. The butterfly effect isn't just a scientific curiosity. It's a profound philosophical insight into the nature of reality itself, reminding us that even in a world governed by rules, true certainty remains an elusive dream. The butterfly effect and chaos theory don't suggest that the universe is random or meaningless. Far from it, they reveal a universe that is incredibly rich, dynamic, and interconnected, where every tiny detail matters. It's a universe where order can emerge from chaos, and chaos can emerge from order, in a continuous, mesmerizing dance. It's a reminder that even the most subtle forces can sculpt our reality in profound ways. So, the next time you hear a weather forecast, or observe a complex system around here, remember the butterfly. Remember that tiny flap of a wing, and the immense, beautiful, and sometimes bewildering consequences it can unleash. What other hidden patterns and connections are waiting to be discovered? Keep exploring, keep questioning, and if you want to keep unraveling the universe's most fascinating mysteries with us, make sure to hit that subscribe button. Thanks for watching, and we'll see you in the next video. The journey into the neuroscience of awareness is far from over. It's a testament to the incredible power of scientific inquiry that we can even begin to ask these questions, let alone devise experiments to seek answers. Your brain, in this very moment, is engaged in an astounding feat of information processing and integration, allowing you to ponder your own existence. It reminds us that the greatest mysteries often lie not in the distant cosmos, but within the confines of our own minds. As we continue to peel back the layers of this fascinating puzzle, we gain not only a deeper understanding of our biology but also a profound appreciation for the sheer wonder of being conscious. Keep exploring, keep questioning, and if you enjoyed this journey into the mind, make sure to like this video, share your thoughts in the comments below, and subscribe for more explorations into the wonders of science.